Good afternoon, everyone. Yeah, so even today, you have to complete the courses. This is the time that I've thought of giving you guys to complete all the 9 things.
So, good afternoon, everyone. So, I hope everyone is here. So, what are we discussing today? We've gone through the prompt engineering, right? So, what are the techniques? What are the key principles we have seen? See, those three main key principles are very essential. Okay, you need to remember that, you need to follow that flow. So, in order to give your prompt perfectly, you need to make sure that your prompt is making sure clarity. I mean, you're mentioning everything clearly. Okay, providing background info, and along with the content, we need to be very specific. Okay, we need to be very specific. So these are all the three main key principles which we need to focus on. Okay, while doing the prompting. So let me just share the screen. Yes. Hope I was able to. So we'll be discussing about the vector databases, okay, which is an important topic now. Okay. I mean, nowadays everyone is opting to go for this vector databases. Okay. What exactly the vector database is? What are its important? What is it? What are the important features, and also we'll be seeing how we are storing it. What are the different types of methods? What is cosine similarity? Okay, how the semantic search is happening. We'll see those things. Okay. Yeah, we'll cover the functionalities, benefits, and also the market landscape. Okay. So, some word into vector databases. So, how things got evolved. Okay. Now, maybe we all know text representation in natural language processing. The text representation is of is in the format of word embeddings. Okay. Word embeddings. Word embeddings of types. See, if you say word to vector, okay, the words will be converted into a vector, and in that also we are having two types, SIBO, okay, and skipgram. SIBO is nothing but continuous bag of words, okay. SIBO is continuous bag of words, and skipgram is nothing but it will be working based on the grams, okay. Grams in the sense like the number of characters you want to consider, okay. Let's say there is a word. Let's say there is a word name posting, okay. So how many characters do you want to consider from that particular word? So that will be decided through n grams, okay? N grams, fine. So, and on the other side, we are having globe. What is globe? Globe is nothing but global vectors, okay? Globe is nothing but global vectors. And we're also having these transformers, how they are understanding, they were understanding based on the contextual embeddings, okay? Contextual embeddings. And in these contextual embeddings, what are we having? We are having semantic vector search, vector similarity, and from the vector similarity, we got these vector databases. Okay, we got the vector databases. So, what is this contextual embeddings? See, transformers are well known for their contextual understanding. Correct. Transformers are well known for their context understanding, and semantic vector search is nothing but based on the meaning of that particular query which you are asking, the related content will be fetched. Okay, according to the meaning, not according to the word match, but according to the meaning, the words will be fetched. Okay, semantic vector search. Remember this, not according to the word match, but it will work according to the meaning. What kind of question are you asking? And it will be fetching the relevant vectors from the vector database, and it will arrange them, and it will be giving the output. Okay, by understanding the context, what exactly that you are asking. Okay, so we will be calling that as a semantic vector search. Okay, semantic vector search. Then comes the vector similarity. Vector similarity search. So based on the similar vectors, it will do the search. Okay, there is a similarity search. Under the similarity search, also we will have the cosine similarity. Okay, cosine similarity. Cosine similarity, how it will be working? It will fetch the relevant vectors. Okay, cosine similarity is nothing but it will fetch the relevant vector. It will work on a formula. Like the formula will be like x2 minus x1 plus y2 minus y1 whole square. Okay, for the both x2 minus x1 whole square plus y2 minus y1 whole square, this whole formula will be under root. Okay, so that is a formula for cosine similarity. And cosine similarity, what it will make sure, it will fetch the relevant keywords. Okay, relevant keywords. So let's say you are having an NLP. Just a moment.
Sorry everyone for the interruption. It's just miscommunication. As you all might be wondering what was that all about. It's nothing but NLP. So as he has already started something, so I'll also introduce you to what natural language processing is. So today we will look at what natural language processing is for some time. But for this, you don't have any course link or others. I'll just tell you in brief about that, so that you can have a better understanding whenever someone asks what natural language processing is. By that you can gain some knowledge. Also, after some time, I'll give you guys time to complete the links, that is courses. I hope everyone has all the course links with them, including the IBM one. Within a minute, I'll share my screen and we will look about what natural language processing is. Give me a minute time. Yeah, guys, regarding project, that is not immediately, that is not a thing that can be given immediately. I hope they are working on it. So what has to be given? But I have been told that there will be a session for project development. As I've already told, I'll myself declare whenever when it is. So please have some patience and don't worry about that. Project will be given, development session will be given, and you guys please don't worry about that. Okay, they'll work, they're looking on it. They'll let you guys know as soon as you'll first they'll let me know. After I'll get to know, I'll definitely tell you guys when will it be conducted. Also, regarding last date, you have to complete all the 8 courses by now. But I'll give you guys time, like today or tomorrow. Within tomorrow, you try completing everything, like all the 9 things. I hope everyone are clear with the links, courses, and everything. So let's now go into natural language processing. Let us look into that. Yeah, so no one has doubts or like no one has understood. Let me know anything or let me know at least something. Yeah, yeah, guys. Okay, so whatever you're all not responding. Yeah, so I hope everyone has got a basic idea of what NLP is. It's just teaching your computer to communicate with you or like with other people in a natural way, just as how we speak with our friends or the people around us. Yeah, as you can see here, NLP, natural language processing, it is the study of interaction between computers and human languages. NLP is what it is: computer science plus AI plus computers linguistics. That is all. Yeah, can anyone guys again regarding project? There's nothing I have told about project. I have just told that there will be a session that will be scheduled regarding project development. Till now, we don't have anything regarding project. You guys, please focus on completing the courses. That is what I have been telling. I have told nothing regarding project, guys. Yeah, I hope you can understand. Also, can anyone tell me if you all have an idea or you can give an example of NLP? Like you guys can see it in everyday life, day to day life. The best example of NLP. Yeah, at least a person or anyone try giving an example of NLP. I'm sure that you might have gone through that or you might have been using, like most of us will be using that. Can anyone guess or at least understand what NLP, or just give me an example? Like, what do you think about that? Yeah, no one's responding. So, okay. Yeah, so whoever has told Ram, I guess, yeah, that's correct. Yeah, yeah, everyone's responding. Yeah, that's absolutely right. Alexa, Google Siri, our Google Assistant, also Siri, Alexa. Yeah, all of them are examples. All of these are examples of NLP. So, what happens there? If we take an example of our Alexa, you'll ask it, okay, hey Alexa, tell me today's weather. Like, what do? You just communicate it just as you ask your friend. What does it do? It will give us a reply, just as a normal human does. So, have you all wondered what's behind all of this? Like, how will even Alexa, a computer, or a model understand your language? Yeah, it is a lot, like it's just too much in between. So what all happens is, when we feed all the information to our model, various things happen there, like tokenization. These, I'm just introducing you guys to the terms. Like, we have tokenization, part of speech tagging, named entity recognition, sentiment analysis, translation of text, also natural language generation. So what happens from the various or huge amount of data that we feed the machine? What happens there? It structures the data, like it just creates human-like text. Like, it also identifies the sentiment, like what is the tone of the speaker, Also if it is positive or negative or neutral, through all of these, and it divides the word into several segments. So whenever I ask Alexa what's today's weather, it identifies my tone as positive, or you can even consider it as neutral. Whenever I am being excited and I ask, it takes it as positive. So similarly it analyzes the sentiment. Also it classifies my text. What is the text? What is the weather? Like what is today's weather? It classifies everything, and based on all of this, like it breaks down our text into smaller units. Also it identifies the words, nouns, adjectives, and all of these parts of speech from our like that sentence, right? From that sentence it identifies everything, and then it classifies. Also it identifies people, organizations, locations, and all of these. So from all of these, what will it say? Hello, so today's weather is 25 degrees Celsius. It will respond to me in that way. So I can tell this as a two-way conversation, right? Yeah, I hope everyone's clear about this. So as of this, it becomes communication. What happens? The communication between a machine and a human. Yeah, I hope now everyone have got an idea. Yeah, you can look at it. So, as I've just now discussed, these are the various things: part POS tagging, NER, named entity recognition, also sentiment analysis. Yeah, I have also told about text generation, translation. You guys can have a look at them. These are the various things that happens behind, uh, which helps us to communicate with the machine. So when all of these things happen, then you can communicate with your system. Yeah, I hope you all can look Yeah, so these are the various things that happen behind which we might not be aware of. Yeah, so to convert something from speech to text, what happens? This is all involved behind. What happens first? There's a text. So whatever it is, if it might be a text, what happens? The processing of text happens. Like what are the necessary information that has to be grabbed from the text is selected, and the text is processed. And later, what happens? Feature extraction. Some features that are important or on which the analysis has to be done are taken. Like if you take we have passages, right? Like comprehensions, right? I hope everyone's aware of that. So whenever we try to find answers from the large paragraph, what do we need? We have to process each and everything, like the whole text has to be processed. But for answering questions, we need only specific things, like a specific paragraph or only the specific lines we need. So this is what meant by feature extraction. So some features that are required are extracted, not the whole information is processed. Also, next what happens? Lifelike speech generation. Then and from that text or from the features that have been extracted, a speech will be generated. And at last, speech. So, and all this happens from the text to speech, like inside our Alexa, or you might take Google Assistant. So, what happens? You just type anything or you speak anything, then it replies you with a speech. Like it generates the speech and it lets you know, right? Yeah, you can have a look at this. So, this is all the process behind that just goes on. I hope everyone's following too. Yeah, I hope you might have gone through them. Yeah, let us move forward. Yeah, so moving on further, what do we have? Yeah, you can have a look at them. What happens? This is image captioning. Yeah, for suppose you have an image. This is an image. When you detect all the objects here, the captions are all displaying. I'm sorry, not captions. Just the names are displaying. So from this, what happens? Words are generated, and then sentences from words, and then like rearrangement of sentences happen there. Yeah, as you all can see here, what can you see there? There's a woman. Also, there's so much crowd. There's another woman who has wore purple coat. Also, she's holding something. Also, there's another woman. We also have camera and all of these things. Hope you all can look into that. So what happens here? We are generating text or we are generating sentences from an image. Yeah, as you can see, there's no cat there, but it has assumed the color of the hair to be that of cats. But just it just assumed, it has created some texts from the image. What happens? First, it detected the words. Like, what are the words? They are women, camera, cat, crowd, purple, and holding. So, from all these words, it tries to generate a sentence. A purple camera with a woman holding a camera in a crowd. So these are the possible things that can be generated. Like whenever the words, what are they? These are text, right? What happens here? Tokenization happens here. That is, large sentences are broken down, and from small words, sentences are generated. So this is also information retrieval. So from these words, all the possible sentences are noted down, and at last, a meaningful sentence that suits the image is generated. So as you all can see, what kind of sentences can be generated from the image. They are a purple camera with a woman holding a camera in the crowd, also a woman holding a cat, also a cat looking at a camera, and women holding camera in a crowd with a cat. So many types of sentences can be generated, but the accurate one that matches with the image is to be taken. So what happens here? Re-ranking the sentences. A woman holding camera in a crowd. So yeah, do you all agree with this? This is the correct sentence that has been generated. You can also have a look at it for some time. Yeah, this is all about. So what happened here? There's some image of a dish, and here captions are generated. So that's why similar to this, we have an image and a sentence or caption written over there, so that we'll have a clear idea whenever we look at the image. So the image just tells that there exists a woman that is holding a camera in a crowd. Yeah, don't you have the links? Even yesterday I shared all the 8 links. So you guys want me to share all the 8 links again? Yeah, I hope everyone's clear about that. So, why do we have so much confusion here? Like, from one word, several words can be generated, right? So, this also affects NLP. Like, we even have an issue regarding ambiguity. So, we also have measures to reduce ambiguity. That is another thing. Yeah, so okay, as we have looked about NLP, now we'll continue further tomorrow about NLP. But for today, I'll share you guys the link. You guys try completing all of them. Yeah, you guys need not worry. I'll share you all the links, and you complete them today. That's it. Yeah, give me a minute. I'll share you guys all the links again. I hope everyone have received the course links. And if you see, I have sent them from the start. Like we have started with Python basics, and same as how we dealt with the topics, I have sent them. Please look into that. I have also shared the IBM one. You can also complete that. So if they are not played, please leave them and try continuing with others. Yeah, regarding that issue, as I've already told, I have already taken this issue. They are discussing about that. It will be resolved shortly. Don't worry, as it is an issue, I will also give you guys to complete that. Like, I'll give you extra time to complete that specific course. Yeah, don't worry. They are resolving it. They are looking after that. If you are only left out with that part, please leave that. So whatever you are not able to access, they are resolving, and I'll let you guys know when once it is resolved. If you have completed all of them, try completing IBM one, or if you have even completed all of them, then you can wait for a while so that we can move further. Tomorrow is not the last day. It will be extended till when the course will be accessible. Like many have raised issue in OS part, right? That part of the course. So once that will be resolved and everyone completes that, we can move further. I hope everyone are clear with this. Yeah, okay. Thank you, everyone.